simplest form. So when the greatest common factor, GCF, of a numerator and denominator is 1, the fraction is in simplest form. Write each expression in simplest form. 6/24. Can you write that in simplest form for me, Zainab? 1/4. Now let me break this down a little bit for you because for the sake of solving equations, this is useful. 6/24. Well, 24 I can think about as 6 times 4. Are we good? And then I have a 6 in the numerator and the denominator. Those will cancel. They become 1s. And then 4 times 1 is 4, and then 1 in the numerator. Do you guys understand why it's 1/4? Okay. The next problem, 8 times 4 in the numerator divided by 8. Who's got this one? We'll go to Ben. What's that going to be? It's going to be 4, correct. And actually, for the same reason I canceled my 6's, the 8's will cancel. They become 1. 1 times 4 is 4. And then in the denominator, 1 is what we have in the denominator. Are we good? Okay. Now, for this problem right here, there's a couple ways I could work this out. I'll show you one way. But first, I'd like to hear, Jose, what was your answer?
1.
Right. So how did you simplify this down to be 1?
Well, I can multiply 7 times 3 and then 21.
Right. That's one way to do it. So the 7 times 3 becomes 21, so the numerator is now 21, and the denominator is still 21. And now you have a numerator and denominator equal, so what's that going to equal? That equals 1. So that's one way to do it. The other way to do it is similar to what I did above. If I have 7 times 3 in the numerator, the denominator I could rewrite as 7 times 3 also. And then we see that I have 1 here times the 3 factors that became 1, which is going to equal 1 over 1, which equals 1. Just another way to think about it. Another longer way to think about it. Okay, any questions about the warm-up? All right, so on to today's lesson. All right. Oh, we had one more? My bad. Here you go. Boom. Who's got this last problem over here? Rayhan, go ahead.
So, as you can see, since I canceled out 3 and 3,
Right.
that's only A.
Uh-huh. So we're left with just A. You can think about this, 1A, 1A over 1 equals just A. All right, any questions? Yep, Osman. No, A, we don't know what A is. A could be anything. If I don't have a coefficient in front of A, I could put a 1 in front of it. Okay, but I have a number in front of A. Right, it was a 3, and then the 3's went away. Okay, yep.
I put A over 1, so that's the same.
A over 1's the same thing. What's A divided by 1? What's anything divided by 1? What's 5 divided by 1? It's the same thing, right? Okay, we good? That's good. Those are good questions. All right, because you're going to see that happening in algebra a lot. And just so you know that a lot of times it just means the same thing. Moving along. Okay, what you learned. To solve equations by multiplying or dividing. The new vocabulary, this should sound familiar to you from the last lesson. Division property of equality, multiplying property of equality. What does that sound like? Anybody? You guys don't remember that from the last lesson? Justin? Right, we learned about the addition property of equality and the subtraction property of equality. So today we're talking about multiplication property of equality and division property of equality. Okay? Why learn this? To solve equations by multiplying or dividing. If you know how to solve equations by multiplying and dividing, you can solve everyday problems such as sharing the cost of a meal with friends. You and 3 friends go out for pizza. An extra large pizza and 4 bottles of water cost $22.68, including tax and a $2 coupon. How much does each person owe if you split the bill equally? Well, here's the first thing I've noticed throughout the day, is a lot of students wanted to say, you're just going to divide by 3, but that's not true. You have to look at this. It's you. How many is you? 1. And then the word and means what? Plus. And then 3 friends. So altogether, what's the total? So we got 4 total. Okay, keep that in mind. So you can represent the problem with the model below. Let P represent the amount of money each person owes. So if you take a look down here, we have the total bill. And we're going to split the total bill how many ways? 4. And if you look, I have P here, P here, P here, P here. They're the same width and area as bill, total bill. Do you guys see that? So it's basically the total bill split into 4 equal parts. That's what each of these P's are. They're a fourth of the bill, right? The total bill. Now if I rewrote this, P plus P plus P plus P is 4P. And that's equal to $22.68. You guys see that? So we have our equation. The model shows that you can use the equation 4p equals 22 and 68 hundredths to solve this equation. You can use the division property of equality. Okay, now let's talk about division property of equality. Here's the division property of equality. It's the key concept for this lesson. Okay, if you divide each side of an equation by the same non-zero number, the 2 sides remain 0. Why do we not want it to be 0? Do you guys remember that from earlier? Why should we never divide by 0? Yes?
It just makes you.
No, not true. Rayhan, what's it?
Because they give you the same thing, 7 divided by 0.
No, no. I said this before. The denominator should never be 0. You can never divide by 0 because it's what? Do you guys remember? Comes up again. Especially in algebra, it'll come up. Yes? Actually, we had a word for this, and we're gonna hear about this more. It's undefined. You can't divide by 0. It's undefined. And so as you continue in your studies in math, you're going to see why. You're going to learn more about this. Justin? It's just, in math, it's undefined. It does not exist. So you'll see, sometimes you'll hear it referred to both ways. Undefined does not exist, and we'll talk about that later, okay? So here we have some examples. Here's an arithmetic example. You can think about this as a numerical expression, or numerical equation. That's an example. And over here we have an algebraic equation, or an equation, a numerical expression, okay, and then an algebraic. That's kind of how I'm trying to connect you with what we've covered before. And all that's saying that, hey, look, as long as I divide both sides of the equal sign by the same thing, over here I'm dividing by the same thing, it's still a true statement. Does that make sense? If the two things are equal and I divide by the same thing, both sides of the equation, I still have something that's true. They're both still equal. Got it? Okay. Division is the inverse operation of multiplication. Remember on Friday we were talking about doing the opposite of add, which is what? We were subtracting something. Or we had to add something by doing what? Subtracting. And we had to do it to both sides. We had to treat both sides equally for it to still be true, right? Well, we're doing the same thing today, but in this example, we're going to undo multiplication by dividing. And so let's take a look at the example from the restaurant where we bought this pizza and we're splitting it between the 4 of us. So here's my equation that we saw earlier. 4p equals 22 and 68 hundredths. To solve this, what's happening between the 4 and the p? Right, and how do I undo, and we're multiplying by what? Not, p is multiplied to something else. What is it multiplied to? To 4, right? So p is multiplied to 4. And so I need to undo multiply by 4. How do we undo multiply by 4? We're going to divide by 4. So the equality, multiplication, or division property of equality says we got to do it to both sides in order for it to still be true. Do you guys understand? So just like we did on Friday with adding and subtracting equality, okay, property of equality, we have to do that here as well for division. Now, if you look at the left-hand side of the equation, that looks a lot like our warm-up, right? And what did our warm-up tell us 4p over 4 would be? What does that become? 1p or p, right? And then this part over here, 22 and 6800ths divided by 4, what do you get when you do that? Can you guys work that out really quickly? And that's a little bit of review for you. You guys should know how to do long division with decimals. In case you forgot, what number goes inside the house, the numerator or the denominator? The numerator. Good. For those that maybe forgot. Go and work it out. Does anybody have an answer for me? McKinley, thanks for joining us today. What happens? What do I get?
I got
5.67. That's what we get? You guys got that? Okay. I still have a few kids that don't know how to do long division with decimals. This is some review for you. Try to get the same thing I have. Just to kind of clarify some things. For those that don't remember the steps. Okay, when I divide this out, we know this is going to become 1p, because 4 divided by 4 is 1. I get 1p, and this becomes 5 and 6700ths. Very good. 1 times p, the identity property of multiplication makes that into a what? P. So I got p equals 5 and 6700ths. Question?
Like when you're dividing 4p divided by p, since it'll equal p, so can't you just skip writing 1p, just instead do p?
Yes, but I want everybody to understand why it becomes just p, okay? Because that's going to be useful later. And eventually, you're right, eventually that'll be a step that you mentally do, okay? But for now, not everybody's ready to just mentally do that step, okay? Now, what I need you to do for these one-step equations, there's not as many opportunities for errors to be made. But when you do multi-step, two-step equations, go back, substitute your answer back into your equation to make sure you got it correct. So here, my p equals 5 and 6700ths. I need to plug it in for p. So here's what I got. I plug it in. I verify it. If you forgot, do you guys see why I moved my decimal at the end 2 places? Why did I do that? Do you remember? Yes.
There's 2 places behind 5 and 67.
Yes, there's 2 places behind 5 and 6700ths. No places behind the 4, so I got to move the decimal in 2 places for my final product when I'm checking my work. Are we good? Okay. Now let's get into some examples on our own. That was the one I did for you, with you. Here's one you need to do on your own. Try this. Try. This is the try part. Okay, I think I went from Ben, Justin, India. What's the first step? Okay, that's part of it, but first thing I always want you to do is I want you to figure out where are my variables? Which side of my equation do I have a variable? On the left side, okay. On the left side of the equation, what do I have with my variable? 3. What's happening with 3 and the x? Well, don't tell me what you want to do. Tell me what's happening. What is this? 3 and the x, what's happening between those two things? It's a what? When we see two things next to each other like that, what's happening? What's the operation? It's 3 times x, right? So I need to undo 3 times x. How do I undo 3 times x? How do I undo times 3? Divide. Divide by what? Divide by what?
21.
No, I'm not going to divide by 21. Don't even look at that. I want to get rid of multiply by 3. How do I get rid of multiply by 3? What's the opposite operation of multiply? Right, so I need to divide. And what do I need to divide by? No, I'm not going to divide by x. I'm going to divide by 3. And I got to do that to both sides. Because my goal is to get x by itself. So I need to get rid of whatever else is there with x. So I have a times 3. So I'm going to get rid of times 3 by dividing both sides by 3. Because the division property equality says I got to do the same thing to both sides of an equation. Now, what's 3x divided by 3 going to become? Not 1, 1x, right? And then we know 1x is going to become, it's just going to become x. Very good. But now we got to work on this fraction here. It's an improper fraction. I got negative 21 and 6/10 divided by a positive 3. So what's that going to become? Correct. It's going to be negative because if I take a negative divided by a positive, that's the magnitude, but the sign is going to be a negative 7 and 2/10. Okay? And then 1x, that's just x. X equals negative 7 and 2/10. Okay, are we good? Now, we should always go back and check our work. So let's substitute for x into 3 into my equation. I can verify that over here. When I multiply it, it checks out. Okay, any questions so far? All right, moving right along. Next one, let's solve this one. Question?
I have a question about where you said the check one.
So if you look, I have, oops, you're right. That should be a 3. Let me fix that. Typo, sorry.
It says like times 5.67 instead of 7.2 and
Right, that whole thing is just, I copied and pasted from another problem. That's wrong. So this whole thing should be 3 times 7.2, and that should give me back 21, 6. That's a negative, so that means this has to be a negative. So negative 21.6 equals negative 21.6. Okay, I'll fix that, thanks. Athila, walk me through this. What's the first thing I gotta figure out? Right, are you sure just 12? Slide back one seat. What's in front of my y? What's that? No, in front of y. That would be in front of y. The left side of y. Right, but you're dividing by 12 though. Should we divide by 12?
Don't you have to like forget about the sign?
No. We're not forgetting about the sign. I want to get rid of negative 12. I don't want to get rid of just 12. I want to get rid of negative 12. So I'm not going to divide by 12. I'm going to divide by negative 12. Because if I divide by a 12, then I get a negative 1y. Do you understand? I don't want a negative 1y. I just want y in the end. Do you understand why we have to divide by a negative 12? So what I get over here, that's what I want to get rid of. Okay, I'm multiplying by negative 12, so to undo multiply by negative 12, I have to divide both sides by negative 12. Does that make sense? Okay, your way will get you there, but the signs are going to throw it off. There's a way to fix it, but I don't want to talk about it just yet. Okay, so do you understand why we took this step instead? Why it's a negative 12 instead of a positive 12? Okay, so moving along, we know that the left-hand side, what's that going to simplify to? Not 0.
Just y.
It's just going to be y, okay? And I feel like we've seen that enough to where we understand why it's just y, okay? But then over here, what's going to happen over here? I have a negative divided by a negative, right? So what's the sign of my quotient going to be? It's going to be a positive. Now we need to figure out what's 108 divided by 12. 9. Everybody got 9? Okay. And does everybody understand why it's a positive 9? Okay? Because if you multiply or divide by the same sign, the result is going to be a positive number. 1y equals 9, or y equals 9. If we check it, here's what we get. A negative 12 times a positive 9 is a negative 108. That's equal to negative 108. Check it. Next problem. Go ahead. Have you worked this out? Okay, well, you're distracting right there. So you weren't very concerned with not being able to see the board because you're flapping your arms everywhere. Slide over one. Make do with what you got. Okay, Teray, you got this one?
Yes. So first, you have to determine the sign and what the order of operation is, and 104 times x, so it's multiplication.
Right.
And you have to reverse that and cancel that out, so you divide
Okay.
by 104.
Right, so we have 104 times x. We have to do the opposite operation, which is divide. So we're going to divide by 104. But we're not just going to divide one side by 104. We have to do both sides because that's what we have to do. That's what the property says, multiplication property of equality. We have to do the same thing to both sides, okay?
And then 104 divided by 104 equals x.
Okay, so the left-hand side of the equation is going to simplify to become x. That's correct. What about the right-hand side?
It will equal 3.
Very good. So 104 divided by 104 is 1. I got x. 312 divided by 104 is 3. 1 times x is going to be equal to x, so x equals 3. If we go back and verify, check our answer, 104 times 3 is 312. Here's the work to confirm. Any question? Okay. So the way I'm trying to get you guys to think about this, you're probably not going to see its usefulness till we get to 2-step, 3-step, 4-step equations. Then you'll see, okay, now I see why we're supposed to think about it this way. India.
Can you cross it?
You mean, could you have just done this? okay, on the same side, but you couldn't cross-cancel from one side to the other. I have to treat this as one thing to simplify, okay? All right, and then this other right-hand side is one thing to simplify, okay? All right, moving right along. Here we go. Here's a word problem. You can use division property of equality and inverse operations to solve real-world applications. I'm going to read the word problem to you. Your cellular telephone bill shows that you were charged an extra $8.58 this month for going over your allotted minutes. The company charges 39 cents for each extra minute. How many extra minutes did you use? So first you need to make an equation that models this problem. And then you need to solve your equation. And it doesn't matter what variable you use. Use a variable that makes sense to you. Okay. Who's got an equation for me? Osman, what's your equation? What's that? Well, try to piece something together. Take a guess. Well, tell me what you got. It doesn't. If you don't have it correct, that's fine. We're going to bounce ideas off of it. You might help somebody else get the right one. You know what? That's correct. I didn't use X. I used M. Does it matter? No. Why do you think I used M? For minutes, right? I could have used T for time, right? It doesn't matter. X, T, whatever. But the number, the cost per minute I go over times the number of minutes, right, equals how much they charge me for going over, right? So you're correct. All right? So, how do we solve it now? Nice. So we're going to divide both sides, correct, by 0 and 39 hundredths. Okay, you have to do the same to both sides, correct? And then, did you get an answer for that? Did anybody else get an answer for that? That's divided. Sounds like some of you might have been further along. Kimberly. 22 minutes. Now listen, some of you guys might have forgotten this. If I divide two numbers that are decimals, the number on the outside should not be a decimal number. I have to make it to a whole number. Do you guys remember us going over this earlier in the year? I have to move the decimal all the way to the end to make it a whole number. If I move it 2 places on the outside, I have to move it 2 places on the inside. If I don't have enough digits on the inside, I have to annex zeros. Remember those terms? Okay, but we didn't have to here. It's kind of easy. So when you divide it out, here's what we get. It's 22. So 1m equals 22, or minutes equals 22 minutes. Yep.
So my equation is a little different. Like I did 858 equals 0.39 times m, or
That's the same equation. You just switch the side that your variable's on.
yeah.
Same equation. And it would have been the same thing. You would have looked and saw your m was on the right-hand side, and then found what was with m on the right-hand side, and you still would have divided both sides by 39 hundredths, right? Okay. Okay, make sure you label your units. All right, here's the next one. Suppose you and your 4 friends go to a baseball game. The total cost for 5 tickets is $110. Write and solve an equation to find the cost of 1 ticket. Who's got an equation for me from these 2 rows? Go ahead.
And I put A in parentheses.
Okay.
Equals $110.
Okay, so 5 times, you chose A. I put T for ticket costs equals 110 for the total number of the total price for all the tickets. Okay, when we solve this, what do we have to do?
You have to divide 5 from both sides.
Divide both sides by 5. What is it when I divide both sides by 5? What do I get back?
You get 22.
Ends up being 22 per ticket. If we check it, it checks out. Each admission ticket costs $22. Any questions about that? We're good? All right, moving along. Here's the next key concept. Multiplication property of equality. All that says, if we need to undo a division, we're going to do that with the inverse operation multiplication, and we got to do both sides the same way. If we multiply one side, I got to multiply the other side. And we're going to be strategic about it. We're not going to choose any number. We're going to choose a number that helps us isolate my variable. So, just to recap, multiplication property of equality. If you multiply each side of an equation by the same number, the 2 sides remain equal. And then here's an arithmetic and algebraic example. Division is the inverse operation of multiplication. When a variable is multiplied by a number, you can use division to undo multiplication. Multiplication undoes division. Let's solve this. We're almost done. Just take a guess. This is when it's okay to mess up, but I need you guys to develop some intuition. I need you to try. And then I'm going to work out this, and then I'm going to have a couple more for you to work out. So see if you can get it. That's t. That's a fraction. T, negative 45, equals 5. Equals negative 5. You need to solve that. No, this right here. You got an answer, Jose? Anybody in this 2 rows that I haven't called on today, who has an answer for me? What do we do? What do we do, Leah? We're not going to divide. This is t divided by negative 45, right? On this side. How do I undo divide by negative 45? I got to multiply by negative 45. So over here, I multiply by negative 45. Isn't that multiplying by negative 45? It's just a fraction, but it equals negative 45, right? But multiplication property of equality says I got to do something to both sides, right? So I have to multiply this side by negative 45. All right, well, this is just the warm-up. We've had problems like this before. These cross-cancel. That's what we're talking about when we say cross-cancel. We're multiplying 2 things. All right, that's cross-canceling. Okay, now what does this side become? T over 1, which is t over 1 is going to become what? T. And then what does this become? Negative 5 times a negative 45. There are 2 negatives, so what's the answer sign going to be? It's going to be positive. And then can somebody please tell me what 5 times 45 is going to be?
225.
225, is that what you guys got? And when we verify it over here, we're good. All right, moving right along. Here's another one. Go ahead and solve that problem. Be careful of the signs. Please take the pass next time. Who's got this answer? Who can walk me through this? Take that off your head. Go hang it in the back closet. Dominique, what do we got?
So since it's division, we have to multiply since it's an inverse.
Okay, right, the inverse of divide by 26. Okay, that's one way to think about it. And what's that going to be? Just find a hook, hang it back there on one of the hooks. Any hook. There's plenty of hooks. Find a hook to hang it from. Find a hook to hang it from. I need you to follow directions. I don't know why we're having a difficult time doing that today. Okay, so we're going to multiply. What are we multiplying this side by?
15.
Not 15. Look at the side that's got W. What's with my W over here? 26. And what's happening between W and 26? Right. So how do I undo divide by 26? Multiply by 26. Okay, and then I can't just do it to one side. I got to do both sides, right? Okay. So now, I have the product of two numbers. One's negative, one's positive. What's the sign going to be for the product? Negative. Did you figure out what 15 times 26 is? You got 390? Okay. And this became W over 1 again, just like the last problem. And then W over 1 is just going to become W. And then if we verify it, we could verify it. Negative 390 divided by a positive 26 gives me back a 15. Negative 15. Negative divided by positive gives me a negative. Okay. Now, last slide. The blank states that if you multiply each side of an equation by the same number, the two sides remain equal. If you multiply each side of the equation by the same number, what is it? It's a property. Multiplication property of what? Of equality. Equality means I do the same thing to both sides of the equation. So for this first one, 8g equals negative 25 and 4/10. What property am I going to use to solve that? Did somebody say division property of equality? You're correct. What about this next equation? W over 26 equals negative 15. What is it? Multiplication property of equality. What about this last one? 5, and then I got a dot there. D equals 60. Division property. We got to do the opposite of multiply. Division property. Now, almost done. I need you guys to match. What matches to this first equation? Negative 6y equals 12. Which one of those three choices over there? Divide both sides by negative 6. Good. The second equation, 12y equals negative 6. Which one am I going to do? The third option. Very good. And then the last one, it's y divided by negative 6 equals 12. I got to multiply both sides by negative 6. And then last but not least, we have this model. Write and solve the equation model at the right. What is being modeled here? How many x's does it take to equal 10? 3 x's. So I get 3x equals 10. How do I solve that? No. What's with my x? What's with my x? It's 3 times x. So what am I going to divide by? 3. Divide both sides by 3. What's 3x divided by 3 become? Becomes 1x. And then 10/3 is going to be 3 1/3. X is going to be 3 1/3. So do you see how you're going to be working a lot with fractions? You're not going to, do you understand? All right. Any questions? That's it. Make sure that you guys are